In this question we are given that a particle moves along a straight line, and we are given the velocity of the particle during this time, and the position of the particle is given by the function s of t. And the position at time 0 is equal to 10. The first question is find all values of t in the interval from 2 to 4 for which the speed of the particle is 2. And so we need to find such speed, which is speed is an absolute value of velocity, v of t, that is equal to 2. So this is really what we are being asked here, all such t for which negative 2 plus t squared plus 3t to the power 6 over 5 minus t cubed minus 2 equals 0. And so we need to use a calculator to do that. Let's do that. Let's find all the values of t for which this function is 0. And so let's use the plotting function. Y is equal to absolute value of negative 2 plus, in parentheses, x squared plus 3x close parentheses. And notice that we are using x instead of t here, which doesn't really matter as long as we are using the same variable in the entire exercise. Minus x cubed, and then minus 2 outside of the term. So let's see what window we have. So it's here negative 5 to 5. Our domain is from 2 to 4. So let's enter 2 and let's enter 4 here. And let's draw this graph. Let's see what we get. So we see that there are two zeros at between 3.3 and about 3.5. So let's change the window. Let's make the window from 3 to 3.5, and let's do increments of 0, 0, 1. Because we would like that precision. We'll be finding the value at which this function is 0. Let's do graphing now. So we have those two values here, and let's do trace. Let's go first to the left. We'll get, and note the value of y. It's increasing. So here it is. Here is 0. So x equals 3.1277. 3.128. Let's go to the right. Now to the second point. And again we can see 0 here at a point x equals 3.4734. So it's 3.47 and 3 approximately. So these are the two answers that we have. In this part of the question we are being asked to write an expression involving the integral that gives the position s of t, and then evaluate at time equals 5. So s of t is equal to s at time 0 plus integral from 0 to t v of x dx. And so to evaluate this expression at time t equals 5, you just need to plug in s of 0 equals 10, and then instead of t plug in 5. So s of 5 equals 10 plus integral from 0 to 5. V of x is this expression, -2 plus t squared plus 3t to the power 6 over 5 minus t cubed dt. And so let's use the calculator to calculate this expression. Let's now calculate this expression. So we need to turn on the calculator. S of 0 is 10, plus we need to do integral, so it's mathematics, and this is function integral, enter, from 0 to 5 of velocity, and so velocity is -2 plus open parentheses x squared plus 3x close parentheses to the power 6 divided by 5 minus x cubed dx. And so enter, we will calculate this expression. And so the answer is -9.2073. And so this is the location where it will be, the particle will be after 5 seconds. -9.2073. In this part of the question, we are being asked to find all times t on the interval from 0 to 5 at which the particle changes direction. And so we have to first find v of t, all time t, at which the velocity is 0, and then make sure that the velocity changes signs at those points. So what are those t's? And then check them. And let's use the calculator to find that. In this case, we need to find all the values of t such that the velocity changes from positive to negative or from negative to positive, so all zeros. The values of t at which the velocity is 0 and changes signs. So let's enter first the function for the velocity. -2 plus, in parentheses, x squared plus 3x close parentheses to the power 6 divided by 5 minus x cubed. So this is our function. Let's check what the window we have, and the window is from 0 to 5, and let's graph it. So we can see approximately this is at 0.5 and a little bit more, and this is at 3.3, 3.2 and a little bit more. So let's do 0.5 to 0.7, the window, 0.5 to 0.7, and let's do the increment of 0.1. Let's see what the chart will give us. Okay, and so let's now do tracing. Trace. You can see we are looking for x such that y will be close to 0, and so here it is. So the value of x is 0.53 and 6. 0.536. Now let's go to the second point that we've seen, and we've seen that here the velocity changes sign from negative to positive. Let's go here from the point 3.2 to 3.4, and let's try this again, graph. And we can see here the velocity changes sign from positive to negative. So the particle was going to the right and then stopped and then went back to the left. Let's do the tracing. Again, we are interested to know when y is 0. And so y is 0 at the point 3.317. At the time 3 seconds, 0.317 thousandths. In this question, we are being asked whether the speed of the particle increases or decreases at time t equals 4. So what we need to calculate v of 4, and then we need to calculate acceleration at time 4, t equals 4, and compare the signs of those two. And if the acceleration and the velocity at time equals 4 is the same, then it means that the speed is increasing. And so let's calculate what the function is for acceleration. And so let's differentiate velocity. So a of t is equal to negative 2 is 0, and then this applied chain rule here. So it's 6 over 5 times t squared plus 3t to the power of 1 over 5 times the derivative of t squared plus 3t, which will be 2t plus 3, minus the derivative of t cubed, which is 3t squared. And so we need to calculate v at a point t equals 4 and a at a point t equals 4 and compare them. Let's do that using the calculator. So let's calculate the sign of the velocity and the sign of acceleration at a point t equals 4. And so let's enter first the velocity, negative 2 plus, in parentheses, x squared plus 3x, close parentheses, to the power 6 divided by 5 minus x cubed. That's our velocity function, and then the acceleration is 6 divided by 5 times, open parentheses, x squared plus 3x, close parentheses, to the power 6 over 5 minus 1 is 1 over 5 times the derivative of x squared plus 3x, which is 2 with parentheses, open parentheses, 2x plus 3, close parentheses, minus the derivative of x cubed, which is 3x squared. So this is our acceleration. Let's now look at the window. So we need to know the value at 4. So we don't really need the 0 to 5. We can try 3.5 and let's say 4.5, and we would like to be in the middle. Let's just see, make this point a 0.5, and we don't really know y value, so let's see what the graph shows us. Okay, so we see one of them going way negative and the other one is not shown yet. As we see, there is a calculation going. Okay, the second one is not showing. So let's change the window range. Let's go here and do maybe negative, because it's negative, let's do 25, and then let's do positive 25, and let's see what we will see in this case. So this is a function of velocity and this is function of acceleration, or the other way around, we don't really know on this chart, but they are both negative. So they are both at the point 4, both of them go in the same direction, to the left. The particle goes to the left and even accelerates further. Let's see what the values are. So the first chart is the velocity, and the value is negative 11.4, and then the second chart is acceleration, is negative 22.29. So the speed is increasing.